For the last video for section 4.5, I'd like to give you another option for doing definite integrals using u-substitutions. In order so that you can compare the two different options, I'm going to do the same problem twice, once using each option. Option A is going to be the way that we've been doing definite integrals. So let's work through this one. This one should feel familiar. If we want to find the integral from 1 to 3 of x times 3x squared minus 1 to the 4th dx, we'll make a u-substitution. We will let u equal 3x squared minus 1, which means that du is 6x dx. I'll rewrite the integrand, moving the x over with the dx. And then I'll multiply and divide by 6 so that I have the differential 6x dx. I then change everything over into u's. 6x dx becomes du. 3x minus 1 to the 4th becomes u to the 4th. And we also need to figure out what the new bounds are. If x is equal to 3, then u is equal to 3 times 3 squared minus 1. So that's 3 times 9 minus 1, which is 26. And if x is equal to 1, then u is equal to 3 times 1 squared minus 1, which is 2. So my u-bounds are from 2 to 26. We then calculate the antiderivative. The antiderivative of u to the 4th is 1/5 u to the 5th. And that'll be taken from u equals 2 to u equals 26. A 6 times a 5th is a 30th. So I get 1 over 30 times 26 to the 5th minus 1/30 times 2 to the 5th. And since 26 to the 5th is going to be a great big number, I'm just going to leave it like this. Now, watch as I show you a second way of finding this integral. We'll start off the same way by setting u equal to 3x squared minus 1 and calculating the differential 6x dx. The next step looks the same. I move the x over with the dx and multiply and divide by 6. So that gives me 1/6 the integral of the 6x dx becomes du, and the 3x squared minus 1 becomes u. So 1/6 the integral of u to the 4th du. What's going to be different about this method is I am not going to figure out the u endpoints, but I'm also not going to write 1 and 3. 1 and 3 are not the correct endpoints for u, so I'm just going to leave them blank for now. Now I find the antiderivative of u to the 4th, which is 1/5 u to the 5th. I'll write my bracket down, but I'm not going to put numbers on here because I don't know what the u's are. I didn't calculate them. So this gives me 1/30 of u to the 5th. Now I can substitute that u is equal to 3x squared minus 1. So I have 1/30 of 3x squared minus 1 to the 5th power. And now that I have x's again, I can put my x bounds over here, 1 and 3. So as long as I'm working with u's, I'm not putting the bounds on, but when I get back to x's, I can write that I'm going from x equals 1 to x equals 3. And now let's substitute in. I get 1/30 of 3 times 3 squared minus 1 to the 5th minus 1/30 of 3 times 1 squared minus 1 to the 5th. So coming back up here to the top, that's 1/30 of 27 minus 1 is 26 to the 5th minus 1/30. 3 times 1 squared is 3 minus 1 is 2 to the 5th. And you see we get the same answer both ways. I'll say that in practice, I use option A, the one that I showed you first, 85 to 90% of the time. So almost all of the time, I do things this way. But there are some problems, especially when the endpoints are variables rather than numbers, that I find this option better. Everybody has a personal preference, so try it both ways. If you like option B, feel free to use it every single time. I'm never going to require you to do it one way rather than another, but I will tell you that in most of the examples I do in class, I'm going to be using option A.